Hey everyone, and welcome to this explainer. I am so pumped to be with you today because we are tackling a seriously critical evolution in how we as developers are building software right now. We're diving deep into how we integrate large language models into our architectures. Let's just cut right to the chase. We've all seen this massive surge in AI adoption, right? But the way a lot of us are hooking these models into our systems is, honestly, hitting a massive brick wall. We're talking soaring API costs, wildly unpredictable latency, and systems that just suddenly hallucinate code exactly when you need them to be rock solid. We really need to evolve our approach. We've got to move away from these massive, do-it-all monolithic setups and shift toward a much smarter, decoupled framework.
I want you to be honest with yourself for a second and really think about your current code bases. Are you forcing your LLM to do way too much? It's so common. We treat these incredible models like they're some magical genie in a bottle. We expect them to be the brain, the hands, and the feet of our entire application. We feed in an input, and we literally expect the model to conceptualize it, format it, plan the next steps, execute physical system commands, somehow magically fix our CSS bugs, and, I don't know, maybe order us a pizza while it's at it. But as we're going to see today, expecting your LLM to do everything is a huge architectural trap. So here is our roadmap for today's explainer. We're going to cover 1. The monolithic LLM error. 2. Kernel-based architecture. 3. Mutation, semantic versus technical. 4. Planning and exploration. And finally, 5. The ideal hybrid model. Let's jump right into part 1, the monolithic LLM error. Think about the typical monolithic flow we see in so many new apps today. You've got an objective, you feed it straight into the MLM, and then you just sit back and wait for the model to plan, decide, write a narrative, generate code, prompt images, process audio, and spit out a video. You're asking one single component to do the whole shebang. Listen, when you take a highly complex reasoning engine and you bog it down with physical execution tasks, you are practically begging for context window exhaustion, not to mention absolutely massive token costs. Your system just grinds to a halt because the LLM is spending all its precious processing power figuring out how to push a button rather than focusing on what that button actually means. The physical execution of actions should always be handled by another tool entirely. Which brings us to part 2, kernel-based architecture. If the LLM isn't handling all that physical execution, who is? Well, that requires a completely different mindset. Instead of that monolithic bottleneck, you place a kernel right in the middle of your application to act as the central orchestrator. Think of the kernel like the head chef in a Michelin star kitchen. The head chef reads the ticket coming in from the customer. That's your main objective. But the chef doesn't stop to chop every single onion, sear the steak, and wash the dishes. No way. The chef routes those specific tasks to specialized prep cooks and station chefs. The kernel does exactly this for your software. It takes the physical execution burden completely away from the LLM. So, who are these prep cooks in our software kitchen? Well, the kernel orchestrates highly specialized tools to do the actual heavy lifting. For instance, it might use Playwright to physically navigate dynamic web pages. It uses depth-first search algorithms to rapidly scan through local directories. It taps into a registry for state management, routes the heavy reasoning to a GPT, uses text-to-speech engines for voice, and hands off the heavy video rendering to a robust tool like FFmpeg. In this setup, your LLM is just one very important instrument. It is not the entire band.
All right, moving on to part 3, mutation, semantic versus technical.
To really nail this architecture, you have to grasp format mutation, specifically the difference between semantic transformation and technical transformation. Semantic transformation is where your LLM absolutely shines. This is when you need to take an image, extract a really nuanced description of what's happening, turn that into structured JSON, and generate a human-readable explanation. That requires deep cognitive reasoning. But then you have technical transformation. That's stuff like converting a PNG to an MP4 or taking a raw website DOM and turning it into a screenshot. You absolutely do not need AI for that. Seriously, relying on an LLM to parse a raw DOM for a screenshot can literally cost 100 times more in API fees than just running a simple deterministic script. Specialized tools do this cheaper, faster, and way more reliably. That leads us into part 4, deterministic planning and exploration. We have to apply this exact same logic to how our systems navigate and plan. A perfect real-world example is a web crawl. If your agent is exploring a massive website, you should not be asking an LLM to guess the next click based on some huge, expensive context window. LLMs hallucinate paths. It happens all the time. Instead, an initial action should be followed by a recursive, deterministic algorithm like depth-first search. Let pure math systematically determine the most efficient next step. A compiled algorithm completely removes the guesswork and the hallucination risks. So, what's the payoff for offloading all this rendering and navigation? By handing those deterministic tasks over to Python scripts or Playwright, your LLM is finally set free. It can focus purely on those high-value semantic transformations. The absolute best use of your LLM is to interpret, analyze, explain, teach, and contextualize. That is the exact moment you start getting your money's worth out of these expensive models, when the AI is thinking, not clicking. And that brings us to our final section, Part 5, the ideal hybrid model. When we pull all these principles together, this is the ultimate architectural goal. We're clearly splitting the cognitive load from the physical load. On one side, your LLM is dedicated purely to reasoning, interpretation, high-level planning, and narrative. It is the brain. On the other side, your specialized tools handle the heavy physical lifting. Execution, navigation, rendering, OCR, compilation. It's the muscle. It's a beautifully clean division of labor that completely revolutionizes how your application scales. Which brings us to the core philosophy of this whole explainer. The value is not in doing less with the LLM, but in assigning each responsibility to the component that resolves it best. Decoupling your architecture isn't just some theoretical whiteboard exercise. It matters because it directly results in fewer crashes, massively lower AWS bills, and an application you can actually debug when things go wrong, because your tools are separated and predictable. So I'm going to leave you with this challenge. Look at the software you're building right now. Is your AI predictable, modular, and efficient? Or is it just a monolithic black box treating everything like a nail because it only has a hammer? I challenge you to review your codebases today. Start refactoring toward a mature, kernel-based hybrid architecture and start building smarter. Thank you so much for hanging out with me on this explainer, and we will catch you next time.